Hello, my name is Greg Davis and I would like to welcome you to the CBS ArcSafe webinar for February dealing with data centers. Now, data centers that we've been in range from facilities that were made back in the 1950s to things that are made or being constructed at this time. So you can see a wide range of switchgear throughout all of that, and so we're not going to be showing you everything we could do for every single kind of data center today. We're going to focus more on some of the modern types of circuit breakers. So I'll just talk real briefly about a few of the things you're not going to see today, and then we're going to get into what we're going to show you. If you've got fire pump panels, we've done things for fire pump panels. If you've got the battery rooms and you've got a battery cabinet with a molded case circuit breaker or a on-off switch for that, we've done things for some of those. So while you're not going to see those today, please remember info@CBS ArcSafe is the email address to send us your pictures, or call us at 1-877-472-3389. The things that we are going to show you today are two different types of insulated case breakers, the Magnum DS and the Square D Master Pack. We're going to look at a couple of types of molded case circuit breakers and a couple of different racking systems. Some of the questions we get asked is, why can't I have one system that'll charge, close, and trip all my different types of breakers? So say I've got a data center with Master Pack in one room and I've got it with Magnum DS in the other. And if you'll look at these two systems, it'll answer this question. Here is our racking system. You need to move the camera over this way to show the Magnum DS breaker. And you're going to see that the charging handle's on the left side and the closed trip buttons are on the right side. If we look at our Master Pack over here, we've got our charging handle on the right side and we've got our closed trip in the center of the breaker. So geometry drives the design of how we're going to be able to do things to help you out. Now, some of the things to note with the Master Pack breaker, and this is important, the design we set up, we have the RSA 48 here that's going to limit the range of motion, and nominally it's usually 5 strokes for many of these breakers. However, Eaton would tell you there may be some breakers that will take up to 8 strokes, and so what you'd do is you'd set it to 5 for our RSO3, and you'd go through that and see whether or not it charges all the way to the breaker. If it doesn't, you'd reset the count to 1 on the RSO3 and then check each individual stroke before the spring shows it's charged, so that you get the proper count for that breaker. One of the things to also note is older breakers will show wear. So I carried a Magnum DS breaker on my demonstration truck for 2 years, and initially it was 5, and then over time, because it was the most worn Magnum DS breaker that I know of, it went to 8, 9, and then 10, and we finally had to replace the charging mechanism on the breaker for it to be operating right again after that. So with this, we're going to show you first the RSA 48, then we're going to show you the racking system for this, and we're also going to show you the just simple closed trip system that we have. The RSO3 uses the Milwaukee M18 lithium-ion battery. You'll just want to check to make sure that you've got a good charged battery. So this one shows 4 bars, that's good. Let me get this in here now. It's just clicked in. And what I'm going to do is I'll prop up the RSO3 right here real quick so you can see it. There's 2 umbilical cables, and this does have a radio remote option, though we don't have it today on this system. I've got a 3-pin and a 4-pin cable that I'm going to hook up. The actual first data center that I went into was one with the double-ended Magnum DS breakers at 5,000 amps, and it had a 5,000 amp tie, and I was just like going, wow. So the electricians who were wiring the place had actually asked the contractor if they could have a arc flash study done, and they were the ones that pointed out the high incident energy levels, that when you're dealing with the 5,000 type amp breakers, you got a limited grounding field, you're always going to have high incident energy numbers driven by that. So let's take a look here. We need to set T1 at 3.3, T2 at 3.0, and 5 strokes. So we got to go down on cycles to 5, right there. We got to go down here to 3.3. 3.0 on that. This is 3.3. Right there. And so we've got this set up. So we've got AR is off. We've got our cycle set to 5. T1 is 3.3. T2 is 3.0. And now this is set up to operate. And what I do is I punch charge close once. The T1 and T2 settings are basically the time the motor is going to run for doing the operation. The reason T1 is higher is because it's taking more work going down and less work returning the handle. So now we see that we've got a charged spring here. So now we press the close once and the trip once. And that's the simple operation of the ArcSafe 48. So there is a slight difference in terms of, just to explain, if you've got a fixed mount one, we would need to make sure whether it's a flush or whether it's got a standout. So this is for a standard door panel like this. Places like delivery centers or other things tend to have more fixed breakers, and we want to get pictures of what you got to ensure the proper mounting application is set up for, like, the door locator right here for the closing and opening the door, so that everything's going to fit when you get it. So those are some of our concerns, because we want to make sure when we give you a solution set, you're going to be able to use it. Set this off down. Get this off right there. Now the next thing we're going to show is the MDS 30, and then I'll get into the racking system. This system is simply made for closing and tripping the breaker. Let me move my cart out of the way just a little bit here for a second. So if you look at this, on this side, we've got a little locator that's going to locate right in here at the top of the breaker. And we've got our 2 magnets, and so that's going to have everything line up pretty easily. I do have to charge the spring first manually for this system. And sometimes people ask us, well, do I really have to have a charge close trip system? And what I will tell you that I've seen on other types of insulated case breakers that have been worn heavily, I've seen this in the Middle East on the first generation Emax breakers, is if this charging system gets worn, that breaker can close at the bottom of the last charging stroke. Okay, I've had that happen in some of the facilities I've done demonstrations and training on over there. And I simply have to tell people, the breaker is not supposed to close on its own when you get to the bottom of that last stroke. If you have something like that happen, the breaker is trying to tell you you need maintenance. Okay? So just understand, remote racking and remote switching don't fix a maintenance issue. They can help you identify one, but you got to get it fixed. That's the bottom line. Get this out of the way right there. This magnet goes on. That magnet goes on. Now we'll get our handheld controller and our cable. Most of the data centers today, unlike old ones, The old ones, you'd only have like 3,000 amp mains, whether it was a K-line breaker or a GEAK breaker, is what we'd usually see. But today's facilities, the things that are coming out today, whether you're a bank, whether you're an internet company, whether you're a government facility, something like that, it doesn't matter. We're tending to see the 5,000 amp mains up to 6,300 amp mains as the main incomers on low voltage. And that's what's driving your higher incident energy, is you've got all this amperage you got to move around for all the servers in a limited footprint area, and you don't have that big an area that you can dissipate your arc fault energy. So that's what drives the fact that you've got such high incident energy numbers. You know, you go build a data center in Colorado, well, you're putting it on rock, and you're not going to have a lot of places to get rid of that energy because of that. So now with this, I can turn my power on. I have to hold my enable button down. I'm going to push my close button. Release it once I hear it close. And I can open it and then release it once it's done. So that's the simple setup and the operation of the MDS30 and the use of this system. Not all of our chicken switch series things are wireless yet, so some are still just going to be cable operated like this, whether it's a 30-foot or a 50-foot cable. And know this, you know, I will tell you, I've been in facilities where somebody gets an arc flash study done and they don't look at their own numbers. And they call in and they order something and it says 60-foot arc flash hazard boundary, okay? And so it's just like they order an MDS30. Well, they need a 100-foot cable. We can do that, but we need to know what your sticker says for actual distance. That number means something, and you need to get the proper stuff for getting your employees outside of the arc flash hazard boundary. Okay, so that's just one of the things to understand when you look at this stuff, what you're doing. Kyle, if you could do me a favor and just move this out of the way while I work to get the next thing up here, that'd be nice. All right. The last thing we're going to do with our Magnum DS breakers, we're going to rack it. So this is the updated version of the MDSR1 for remote racking, and it's actually got, again, the Milwaukee M18 battery on it for power. So we'd be able to use this and be away from it. This hooks into the lockout, tagout, and the racking mechanism right here. This is our anchor that moves it and locks it into place. So I have to lift the port here, insert, right into there, lift up the little hook, and I got to get this thing in. Let me check to see how close I am to the orientation here. Okay, I'm just moving the racking mechanism right now to line up with the breaker from just a simple visual inspection. Come on, you're not quite there yet. Almost there. There we go. And then this locks down in here to keep it in place. Okay, so this is our control cable. And again, we have 30, 50, 100-foot control cables. Here's our control and display box. And we have to now connect everything up real quick. Let's see, I need that's the one right there. There we go. Now inside the box is the master power switch, so I have to lift up a red guarded switch, and I'll just show that real quick so you can see that. Okay, so the master power switch is on. We'd want to step outside of the arc flash hazard boundary. We're going to go enable, and because the breaker's in the in position, we're going to hold the out position down.
That work on the mains and the feeders?
It works on the mains and the feeders, and it's going to rack the breaker. I think it's like 38 turns on the racking mechanism to go in and go out. And this will handle all the big breakers too. So it's right now showing in the test position, and we'll get to the disconnect here in just a second. And remember, the test position simply has the secondaries connected, so if you want to run a test there, you can do that. But you can see the indicator in the camera here to show you where you're at. It's going to go all the way to the end, and it's going to release the torque. So I'll hold it down, and then it goes back just a little, about a half a turn. Okay? And so for us to move the breaker back in, it's going to be the exact opposite process. We'll hold the enable button down, and now we're going to go in. And you know, one of the things is we've seen some of our competition have problems getting like the 5,000 amp breaker in. And the Magnum DS breaker, domestically in the United States, the largest one I've seen is 5,000 amps. But the IEC rated breaker is rated up to 6,300 amps. So this will do both of those breakers.
The Milwaukee battery powering that one too?
Yeah. That's going right onto the bus right there, and you can tell it's just spread the finger clusters. And that's it. So that's the remote racking, and then we'll turn it off here at the box, and then we can work to disconnect this and take it off. All you do is lift up the little latch, pop it out, and it goes back in the box here. Now, the insulated case breakers tend to be most of the, what I'd say, are bad actors as far as the mains and the ties in data centers, but we also have some places that have problems with molded case circuit breakers. So what I'm going to do is just move this away for just a second. I'm going to turn the card around. We're going to put the RSO1 up here now. I need to get my M18 battery back real quick. So now the difference between an RSO1 and an RSO3 is that when we first started making things all the way back in 2008 at CBS ArcSafe, as we became CBS ArcSafe, people asked, I need something for just on-off. Okay, well, gee whiz, that's normally a simple function of up, down, twist, or do something like that. So we had simply close and trip as the indicator on here for our simple actions. And then somebody says, well, I got to have a little bit more functionality. And then they say, well, I need to be able to charge, close, and trip. And we're like going, well, we're going to go with an open architecture where anything that's going to be closed trip, we're going to use an RSO1 for. Anything that's going to be charged closed trip, we're going to use an RSO3D for. Okay, so we had to come up with different control boxes, because if somebody's just got closed trip for like motor control centers, that's all they need. And so we weren't going to try and sell you something you didn't need in terms of functionality. Now, we see a lot of power pack breakers, and one of the things to notice is this. This is what we would call a flush mount up here. And then you've got other stuff down here which is recess mounted. So the physical position of how this breaker is mounted matters to us. Is it flush or is it recess mounted? Because we have to be able to locate around this face to be able to operate the breaker. So those are important questions we need answered. So in reality, you could have two of these breakers mounted in here, one flush and then one recessed, and you might need 2 remote switch actuators to actually be able to do what you need to do with it. The breaker's in the open position. We'll turn our RSO1 on. Let me step over to this side so I'm out of the way and you can see this. So now we're going to hit the close button, hold it down. For the entire duration of the operation, for a trip, so some of the funny things is different types of casinos, or no, correction, I just got ahead of myself. Okay, different types of data centers that we've seen. We've seen banks, we've seen internet companies, we've seen government agencies, and we've also seen gambling casinos as customers needing things. So one of the first data centers we dealt with had GE Power Break first generation circuit breakers. Okay, and it was just like, okay, these are different animals, and so we had to develop things for the first generation GE Power Breaks. And then we saw GE second generation Power Breaks in another data center. So it's kind of interesting because it's like, open the door, show us what you got, and we'll work to figure out if we've got a solution or if we have to make a solution for you. But one of the places we dealt with, we are actually doing smaller molded case circuit breakers similar to this as one of their high interest items also. So we haven't done every single molded case circuit breaker yet, but we've done a lot of them. If we need to do a demonstration or a site evaluation, understand domestically in the United States, site evaluations and demonstrations are free. You can call us at 1-877-472-3389 or send us an email at info@cbsarcsafe.com. Now we're going to operate the little breaker, and the little breaker is currently in the, let me just check the position here real quick before I do this. It's in the on position, so we're going to move it to the off position. So we're going to do trip first, and then close. And you can see I'm going to take this RSA off so you can just look at the bottom side of it. But you can see it's mounted like this, where this is the flush part with the face of the switchgear up here, but the breaker itself is recessed about 1.5 inches back from the face of the switchgear. So that's the reason it has to be built like this, is it's got to get to where that face is. And you can see that now with this operation. Let me take this apart real quick and we will get on to the next thing. Now, in a lot of data centers, you'll see, especially newer things, you're going to see a vacuum breaker at each end, usually like 15 kV, with a knife blade switch, and then you're going to see your low voltage 5,000 amp mains on a main-tie-main setup, okay? And this particular thing that we're going to show you next is our Square D VR RS3 system. Let me just set the RSO1 down here for a second, because we're not going to need it anymore. And we use the RSO4 for this one. I'm gonna pull my Milwaukee battery back up here and show it to you. But the reason we came up with the RS3 systems is because somebody says, I don't need an RS1, I just need something for this style of breaker in this substation. Kyle, I will need a red or an orange cable real quick. So I'm gonna just talk here for a second while we go through this. But the medium voltage breakers are usually, again, you'd have one at each end, a knife blade switch, and then you're going to have your tie breakers for the main tie main setup. And understand that when you're doing this, you know, you want to keep people outside of the arc flash hazard boundary. The number of times that I've seen rooms like this, and it's because you're working to design and put all this stuff into a single room, and you can have like 20 plus rooms in a data center that's big, where you got main tie main setups like this. You got to be able to rack these breakers, and you want to be able to also switch them. The one device I don't have to show you today, just to talk about it real quick, is our standard chicken switch, or CS01 breaker control switch. We do have those, and we need to see what kind of switch you're using so that we quote you the proper one. Thank you, sir. And so understand that that whether it's remote racking or remote switching, we probably have a solution for it, even if we don't get to show you something today. Now, the VR breakers that you'll normally see is you're usually dealing with a 1200 amp or a 2000 amp, and that's what you're going to see. Most of what we see in the data centers today are the insulated case. So you're going to see the Magnum series, you're going to see the MasterPack series, you may see the Siemens 3WL series, and you might see Emax breakers, second generation now from ABB, or you may see the GE IntelliGuard G breakers. Okay, so those are what are going into the data centers that we're seeing today. So just to understand that. The RS3 is made for this. Now I will tell you, I was driving back from doing a demonstration out in the Rocky Mountain area, and there was a data center being built, and I got a phone call from the office, and they said they want to buy the RS1 off the back of your truck today. I'm like going, what? They want you to come by, train them, and sell that RS1 right now. And I had to ask why, and they got there, and he says, we will lose 3 days of construction time and have to pay everybody for 3 days because the utility can't get out here to cut the feed unless you can rack that breaker out, and we don't have to pay the utility and lose 3 days of paying everybody. The RS1 that they bought paid for itself that day in terms of not losing the construction time that they needed for being able to do that. Now, I would have never have thought that, but it was literally, they called the office and I was literally within 50 miles of the facility, and they bought the RS1 literally off the back of the truck. So this has install 4.5, remove 3.0. One of the things to understand is breaker manufacturers won't put the torque numbers required for racking a breaker in and out unless you, a customer, demand it. And to be honest, we've only seen 2 manufacturers put the torque recommended inside of their manuals within the last 2012 was the first time I saw it inside of them, and it's not in every single one of those those manufacturers' manuals. So this one of the things to understand is it's something that you, the customer, would have to ask the switchgear manufacturer about. That being said, we've worked to develop the numbers ourselves for these breakers based on experience using torque wrenches and measuring the running torque values so that we work to keep from damaging switchgear in the racking process. So we had to develop the information for ourselves. Now, we have install 4.5, which again, it's going to take more torque usually to get a breaker in than get a breaker out, so that makes sense. So we're going to set 4.5 here for install. And we'll set 3.0 for remove. Oops, too far. Now, if I turn this off, it's going to remember the numbers, so I'll turn it off. I have to wait a few seconds because there's a capacitor in there we want to let die before I take and turn it back on, so I'll just wait. Now I'm going to turn it back on. And it says 4.5 and 3.0, remembers the numbers. Right now we show the breakers in the connected position. I'm going to just move this to, well, it's not going to let me have a green flag, but I want to show a green flag. So we're going to simply put the remove button, hold it down for just a moment. Okay, let me check here. Power on. I'm in local. There we go. I just had to hold it down for a second longer. It shows transport, which just basically means the breaker's moving. And now we're out to the disconnect position. Let's just hit the stop button right here. Okay, now I stood right here, but a RS3 actually comes with a radio remote. And so if I go to power here, it doesn't have the, may not have the batteries in it, but the standard radio remote will get me out to 100 meters. So the cable here is only made to be 8 feet long. The only people that get upset usually as far as wanting a radio remote or not wanting a radio remote are usually places like a nuclear facility. But the standard radio remote is going to get you out to about 100 meters. That's with a clean radio path between the unit and the radio base inside here. So for us to rack the breaker back in now, we're going to push the install button. Okay. Let me say again.
Hit the stop button again to clear it.
Okay. Oh, there it is. Yep. Okay. You have to push the stop button twice to clear the unit from the last operation. Okay, we'll hit our stop button again, and that's it. So that's the operation of an RRS-3. So some people want the portability of the RS3, some people want the universal and the fact they don't have to lift things manually to get things up and down. So whichever application you like, whether it's an RS1 or an RS3, that's up to you, the customer, to define what you want for your operational footprint. The last thing we're going to show is the charge, close, and trip for the Master Pack breaker. Now, the difference between a Master Pack and a Magnum DS breaker is this. The Magnum DS breaker has a fixed stop, and when you try and exceed it, you're going to break a handle. The Master Pack breaker will actually allow you to the end of your strokes. Now, one of the things to note, we've seen, I saw Master Pack breakers down in Mexico, which surprised me because normally we would say it would take 7 strokes to charge the breaker. But I ran into some down there last month, there were 6 strokes. So it's not going to damage the breaker if I keep pumping the arm up and down, but it was surprising that it was like less than what we'd seen before. And it was just, you know, we are always learning from you, the customer, and what you have in your facilities. So we've got 15 plus years of learning, and we learn new stuff every day. So we will share our information to help you be able to safely operate stuff and be able to do this. Again, I've got the 4-pin and the 3-pin. This is, again, different than a Magnum DS breaker just because of how this thing is set up. I'm going to go ahead and leave the cart on that side this time just because it's got better lighting. And I'll get back over on the far side when I actually operate this. So, I've seen data centers in the Dallas-Fort Worth area with double-ended subs and 5,000 amp Magnum DS breakers and also 5,000 amp Master Pack breakers on them. The breakers that you're not seeing also that you may see, if you got big things like the RJ frames for the Square D or the, it's the R frame for the Cutler hammer with the 2,500 to amp breakers, we've got the ArcSafes for those also. Now this says 7, 4.2, and 4.2. So we're going to turn this, actually let me turn the power off. Let's get the breaker, let's get this back on here. Let's turn this on, and now I've got to make this read 7, so I'm going to go up 2, and then I'm going to go 4.2 and 4.2. And that's got that set now. So now, again, if I just hit charge close one time, we're going to start charging the breaker. Now, some of the things to understand is this. The original Master Pack breaker was made by Merlin Garon, and then when they merged and became Schneider and Square D, also being part of it, then it became the NW series. So it went from NP to NW and NT. The NT has got a different system in terms of for doing it. It's not just because it's a different size face. And the current generation is the MTZ. Is that right, Kyle?
Sure.
It's MTZ. So the handle is one of the things to understand is if you had an MP, an NW, and an MTZ, these handle styles will change. I could use this same RSA, but you'd have to have different handles, adapters, for that if you had those in your facility. If you were updating your breakers from NWs to MTZs, doing a modernization type thing, you're just going to need to get a different handle adapter because everything else has stayed in the same place as far as the face of the breaker goes. So now we're going to go close and trip. So those are the operations. Now we want to open it up for questions. Again, you can send your questions to the email during the chat here or info@cbsarcsafe.com or call us at 1-877-472-3389. We'll just give it a minute to see if anybody's going to. I would like to thank everybody for tuning in and let us go and know. You can find these also on our webpage if you missed the webinar today. Thank you again, 1-877-472-3389 or info@cbsarcsafe.com.